Let's solve this problem involving both arithmetic and geometric sequences. We'll break it into two parts. Let's start with part A. We have an arithmetic sequence where the first three terms are 25 for p minus 1 and 13 minus p, where p is a constant. We need to find the 10th term. In an arithmetic sequence, the difference between consecutive terms is constant. Let's call this common difference d. We can find it two ways, either a 2 minus a 1 or a 3 minus a 2. These must be equal. Since these are equal, we can write for p minus 26 equals 14 minus 5p. Solving for p, adding 5p to both sides gives us 9, p equals 40. Therefore, p equals 40 over 9. Now that we know p, we can find the common difference d by substituting p back into either equation. Let's use 4p minus 26. This gives us d equals negative 74 over 9. To find the 10th term, we use the arithmetic sequence formula. A sub n equals a sub 1 plus n minus 1 times d. For the 10th term, we substitute n equals 10. 25 plus 9 times negative 74 over 9 equals negative 49. Now for part B, we have a geometric sequence with first three terms, 25 for q minus 1 and 13 minus q, where q is a positive constant. We need to find the sum to infinity. In a geometric sequence, the ratio between consecutive terms is constant. Let's call this common ratio r. We can find it two ways, a 2 over a 1 or a 3 over a 2. These must be equal. Setting these equal and solving, after multiplying and simplifying, we get a quadratic equation. 16q squared plus 17q minus 324 equals 0. Using the quadratic formula, and remembering that q must be positive, we get q equals 4. Now we can find r. Substituting q equals 4 into either ratio equation gives us r equals 3/5. Since the absolute value of r is less than 1, the sum to infinity exists and equals a sub 1 over 1 minus r. This gives us 25 over 1 minus 3/5, which equals 62.5. Therefore, the 10th term of the arithmetic sequence is negative 49, and the sum to infinity of the geometric sequence is 62.5.